Welcome to learning about Inference. Today, we'll explore one of the most important yet often misunderstood parts of artificial intelligence, how AI actually works. When you interact with it, think of every time you've used a voice assistant, seen a spam filter in action, or gotten a song recommendation. Behind all of those is a process called inference. It's not about learning anymore, it's about doing. We'll walk through what inference is, how it's different from training, and where it happens in your daily life. Whether you're completely new to AI or just want a clear explanation, this session will help you understand how smart systems make decisions in real time. Let's get started. Let's take a quick look at what's ahead in this session. We're going to start by answering the big question, what exactly is AI inference? Then we'll dive into the core ideas like how inference differs from training and why that matters. After that, we'll explore where inference actually takes place, whether it's on powerful cloud servers or right inside your smartphone. You'll see real-world examples like voice assistants and medical tools in action. Then we'll compare different approaches and talk about trade-offs like speed, privacy, and efficiency. Finally, we'll wrap up with practical tips, self-check questions, and ways to keep building your AI knowledge. By the end, you'll be able to recognize inference wherever it happens and even imagine how to use it yourself. Sound good? Let's jump into the first concept. So what exactly is AI inference? Simply put, it's the moment when an AI system puts its knowledge to work. Imagine a student who has spent weeks studying for a final exam. The studying is like training, gathering knowledge. The exam itself is like inference, applying that knowledge to answer questions. In AI, once a model is trained on large amounts of data, it enters the inference phase. That's when it takes new input, like a photo, a voice command, or a sentence, and makes a prediction or decision based on what it learned. For example, when you speak to Alexa, the device records your voice and runs inference to figure out what you said. No new learning happens here. It's purely about using existing knowledge efficiently. And because inference is optimized for speed, it feels instant. This is how AI becomes useful in real life, not while it's being trained, but when it's making split-second decisions. Let's look at how this compares to the training process. Now let's compare inference and training, two phases that are often confused. Think of teaching a child math. During training, it's like hours of practice problems, flashcards, and lessons. The goal is to build deep understanding. That's what happens when an AI model learns from data. It adjusts its internal settings over and over until it gets things right. But once the lesson is over, the real test begins. When that child goes to the store and calculates change, they're not learning, they're applying what they know. That's inference. In AI, training is computationally heavy and can take days or weeks, often on powerful servers. But inference? That's designed to be fast, efficient, and ready for real-time use. For instance, a large language model might take weeks to train, but it can answer your question in under a second. Why? Because during inference, it's not learning anything new, it's just running a well-practiced routine. Most AI apps you use, like search suggestions or face filters, are running inference, not training. So remember, training builds knowledge, inference uses it. Now, where does inference actually happen? There are two main places, in the cloud or on the device, also known as the edge. Let's break that down. Cloud inference means your data is sent to a remote server, processed there, and the result is sent back. It's like streaming a movie. You rely on a distant data center. This approach allows for very powerful computation, which is great for complex tasks like translating entire documents or analyzing medical scans. But it requires internet access and can raise privacy concerns. On the other hand, edge inference runs directly on your device, your phone, watch, or smart speaker. This means no data leaves your device, which enhances privacy and speeds things up. For example, when you unlock your iPhone with Face ID, the facial recognition happens right on the phone. No photos are uploaded. It's fast, secure, and works even offline. So which is better? It depends. Need maximum power and don't mind a slight delay? Use the cloud? Want instant response and strong privacy? Go edge. Many modern AI systems actually use both, choosing the best option based on the situation. You might wonder, how can AI respond so quickly, especially on a phone? The secret lies in optimization. During inference, the model performs a series of mathematical calculations, much like solving a fixed equation. But unlike training where every detail matters, inference can be streamlined. One common technique is called quantization. This means simplifying the numbers inside the model, like rounding decimals to whole numbers, so it takes up less space and runs faster. It's a bit like converting a high-resolution photo to a smaller file size. You lose a little detail, but it loads much quicker. Another key factor is hardware. Devices now come with special chips like GPUs or TPUs designed specifically for AI tasks. These accelerators handle the math far more efficiently than a regular processor. Together, these optimizations allow even large AI models to run in seconds on everyday gadgets. This efficiency isn't just convenient, it's essential. For applications like autonomous vehicles or live medical imaging, delays could be dangerous. Fast, reliable inference makes real-time AI possible. Let's bring this to life with real-world examples. Imagine saying, "Hey Google, turn on the lights." What happens behind the scenes? First, the device captures your voice. Then, a speech-to-text model runs inference to convert your audio into words. Next, a natural language understanding model infers your intent. Is this a command, a question, or a joke? Finally, the system triggers the smart light. All of this happens in under 2 seconds, powered entirely by inference. Now, let's go to a hospital. A doctor uploads a patient's chest X-ray to an AI system. Within moments, the model previously trained on thousands of medical images runs inference and highlights areas that may indicate pneumonia. It doesn't replace the doctor, but it helps speed up diagnosis. Or consider your favorite streaming app. When it suggests a show you might like, that's inference too. The model analyzes your viewing history and predicts what you'll enjoy next, all in real time. These aren't futuristic ideas. They're happening today in homes, hospitals, and phones, thanks to the power of inference. Now it's your turn to apply what you've learned. Let's start with a beginner-friendly exercise. Think of 3 AI-powered features you've used today. Maybe it was predictive text, a navigation suggestion, or a social media feed. For each, write one sentence explaining how inference is involved. Remember, no learning is happening, just using knowledge. Just using knowledge. Got that? Great. Now let's go a step further. Imagine 2 versions of a photo filter app. One sends your picture to the cloud for processing. The other applies filters directly on your phone. Which one is faster? Which protects your privacy better? Which uses more battery? Write down the pros and cons of each. Finally, here's a challenge. Design a simple AI feature, like a chatbot that detects your mood from your messages. Where should the inference happen, on the device or in the cloud? If privacy is key, maybe keep it local. If accuracy is more important, maybe use the cloud. Justify your choice. These activities aren't just busy work, they help solidify your understanding and prepare you for real-world AI thinking. Let's review the key points you've learned today. First, inference is the phase where a trained AI model makes predictions or decisions based on new data. It's not learning, it's applying knowledge. Second, inference is very different from training. Training builds the model. Inference uses it. Training is slow and heavy. Inference is fast and efficient. Third, inference can happen in two main places: in the cloud, on remote servers, or on the edge right on your device. Each has advantages. Cloud offers power, edge offers speed and privacy. Fourth, behind the scenes, inference is optimized using techniques like quantization and special hardware to run quickly, even on phones. And finally, inference powers almost every AI feature you interact with, from voice assistants to medical tools. If you can now explain inference in your own words, give examples, and distinguish it from training, you've mastered the essentials. You're well on your way to understanding how AI works in the real world. Congratulations, you've completed the A Keywords Fast Track on Inference. You now understand one of the most important concepts in practical AI, but your learning doesn't have to stop here. If you're curious to go deeper, consider exploring model optimization, how engineers shrink AI models so they can run on tiny devices, or look into edge AI development, where you can build apps that run inference directly on phones or cameras. You might also want to study how training works so you can appreciate what inference depends on. And don't forget AI ethics. Understanding how inference can reflect biases or impact privacy is just as important as the tech itself. For hands-on practice, try Google's Teachable Machine or TensorFlow Lite. Both let you create models and see inference in action. Join online communities like Learn McNeilian to share ideas and ask questions. Every expert was once a beginner. Keep observing, asking, and experimenting, and soon you'll be explaining AI to others. Thanks for learning with us.